Hi guys, here we have lecture 2 of module 3 quantum mechanics. In this session, we are studying about wave functions and its physical significance and then quantum mechanical operators. So our first topic is wave function. A wave function is a mathematical function which represents the de Broglie wave associated with a moving particle. Also, it describes the whole behavior of a particle associated with that wavelength. And generally, it is represented by psi of r, t, where r and t the position and time components. So, we can write this as psi of x, y, z, t. Instead of r, we can give the position coordinators x, y, z, and t is the time coordinators. It is a complex quantity, and the properties of a wave function is this wave function psi of rt or psi of xt must be single valued and continuous everywhere. Its derivative, if we are taking the partial derivative of this wave function, the derivative must be continuous and single valued everywhere. So these are the properties of a wave function. So then the wave function psi of rt itself has no physical meaning. It only represents the amplitude of the wave associated with the moving particle, whereas the square of its absolute magnitude, modulus of psi square, is the probability of finding the particle in different region of space. So, the probability of finding the particle is modulus of psi square, which is psi star or psi star psi. Then again, psi must be a normalized wave function. Psi, if the particle exists somewhere in the space, then we can write integral minus infinity to infinity modulus of psi square dv is equal to 1. The wave function which obeys the above condition is said to be normalized wave function. So, if psi must be a normalized function, then integral minus infinity to infinity modulus of psi square dv is equal to 1. Then we have operators in quantum mechanics. So for every observable or quantity of classical mechanics, there correspond a linear operator in quantum mechanics. Operators transform one function to another function. So here we have three main operators: energy operator, momentum operator, Hamiltonian operator. So the energy operator E cap is equal to I h cut dou by dou t, and momentum operator P cap is equal to minus I h cut dou by dou x, and then Hamiltonian operator, which is represented by the letter h, is equal to minus h cut square by 2m del square dou x square plus v. Next is eigenvalue and eigen function. When an operator A operates on a function f of x, then the result is a constant A multiplied by the same function f of x. Here A is the operator. With this operator, we are operating the wave function f of x. Then the resultant or the result will be the same wave function with a multiplication of a constant value. This equation is called eigenvalue equation, and the constant is called eigenvalue. F of x is called eigen function. Suppose show that Schrodinger equation is an eigenvalue operator equation. We have the Schrodinger equation minus h cut square by 2m del square psi plus v psi is equal to e psi. So if we are taking psi outside, then minus h cut square by 2m del square plus v into psi is equal to e psi. So we already studied minus h cut square by 2m del square plus v is the Hamiltonian operator. So we have h psi is equal to e psi. So in this, psi is the wave function and this Hamiltonian is the operator here. So we are operating this psi with an operator h. So here we get psi as the output with a constant E. Here E is the energy operator or eigenvalue E and eigenfunction is psi. Okay. So this is the topic. Thank you.